Hi everyone, I am Balaji Chippada and welcome back to my YouTube channel. In this video, we will learn a very important topic, and the topic is core for all of machine learning, which is called Gaussian normal distribution. We will understand what it is and what are the properties of this distribution and how you can utilize this in real world. So without any delay, let's get started. What is a Gaussian distribution and what is a normal distribution? So you might have seen in real life some curves like this, right? So this is like bell shaped curve, and you have the values as 0 here and some values in the x-axis, and you have the y-axis as well. So this is called a Gaussian distribution. We also call it as a bell shaped curve. And before understanding what this is, let's understand why do we need to learn about this distribution and what are the properties of this distribution. Usually in real world, most of the things follow this kind of distribution. I will take some examples so that it will be easy for you to understand. And in most of the cases in real world, the properties follow a Gaussian distribution curve, and how it will be followed, I will explain it in a bit. So let's say I am taking height of people, and then I am also counting people in the particular height. So let's say this is my task. There are 8 billion people. This is my population, and there are many different kinds of people, and their heights might vary, and the number of people who are falling in that particular height bracket might also vary, right? So I will draw this in my x and y axis. So this is my x axis and this is my y axis. And I have always said about this, right? Whenever you are looking at a plot, always ask the first question, what is the axis and what are the values of these axes? So this axis, I will call it as a height of people, and here I will call it as count of people in particular height. Okay, so let's say it starts from 0, 1, 10, 20, 30, 40, 50. So likewise I have up until 250. Let's assume like that. Okay, so when you look at in a generalized way of all the people in the population of the entire world, there are very less number of people who are falling in this region, right? There might not be very large number of people who are under the height of 10, 20 and 30 and 40. We can treat it as centimeters or inches, it could be anything. And there are very less number of people who are very height. So let's say these are under 1 feet and these are under more than 8 feet. There are very less number of people who fall into this category in which they are under less than 1 feet of height, and there are very less number of people who fall under the category in which they are larger than 8 feet of height. And if you take the mid values, which is the median values, there are very large number of people who might fall into this bracket when you look at a generalized way of all the population, right? So if I have to smoothen out the curve, I will draw something like this. Is that clear? So let me explain what this is. So let's take at any particular point. So this point. So let's assume this is like 80 value, something like that. So let's assume it is like 5 feet or 6 feet. So in considering the whole population, there are very large number of people, this is the count, in which they fall into a bracket of 5 feet. Is that clear? And if I say about 8 feet, there are very less number of people who falls under 8 feet, and there are little bit less number of people who fall under 6 feet. Who knows? So usually in the world, whatever you see, this will happen. Actually, there are very less number of people who are having very less height, and very large number of people who are having median height, and very less number of people who are having very large height. And if I smoothen out this whole point, this is called as a bell curve. It is in the inverted shape of a bell, right? And this is also called as Gaussian distribution. And this applies to almost everything in the current world actually. So let's take this one, and we will say number of people who are in the very less weight or very less, and number of people who are more than 200 kg are very less, and number of people who are falling between 40 kg to 160 kg or maybe 100 kg is very large. So if I have to do like this, so this is my weight. There are very less number of people who are very less number of less amount of weight, and very less number of people falling more than 200 kgs of weight, and we have a lot of people falling the median weight values. So this is also called as a bell shaped curve or like Gaussian distribution curve. So it is said that in real world most of the things follow this kind of distribution, but we don't often notice these things. So this is called a Gaussian distribution. I hope you understand what it is. Now the next question comes to it is, why are we learning this? Why are we learning? This is also really important, right? So whenever you say it, the distribution follows a Gaussian distribution, there are some properties to it, and these properties are common across this distribution. So without looking at the data points, I can make some conclusions if I know what kind of distribution my data falls into. So to explain that, let's go into the Wikipedia. I search something like normal distribution. If you look at it, normal distribution. So I got this plot here. So let's understand what this is, and then we will go back to our theory part. So if you see, there are 1, 2, 3, 4 different plots, and all of these are called normal distribution, Gaussian distribution. And here I have my x, which is my random variable, and it is a continuous random variable. And here this is my mean value. If you see mu equal to 0, so this is a mean, and sigma square is called variance, and we will understand what is variance in a bit, so don't worry. So variance is basically how much spread your data is from the mean value. So I will explain variance again. From the mean, how much wide your data is, so that is called variance. We will understand about how to calculate variance and everything in the later videos, but let's understand what the significance of a normal distribution is. And if you look at it, the normal distribution is always symmetric in nature from the mean. So this is my mean value, and if you look at it, this right half and left half are symmetric in nature, and whenever the value of x increases or decreases, the value of y tends to decrease from the mean value. Clear? So, and it decreases in a very faster way, which is exponential decrease. Exponential decrease. Okay, and then this is one of the property, and second property is it is always centered at the mean, and mean could be of anywhere. So if you look at it, the first three plots mean is at 0, but for this plot mean is at -2. But even though the mean value is different, it is centered across the mean. So that is one of the property. And the next property is this variance. So if my variance is 0.2, it is very less spread, see, and if it is 1, it is little bit more spread, and if it is 5, it is very widespread, and if it is 0.5, it is spread like this. So your variance will tell you how spread your data is from your mean. Clear? So this is your y, this is your x, and let me rephrase all the properties. It is always centered across mean, and it is symmetric across the mean, and then based upon the variance value, you can get to see how much wide or narrow your distribution plot is. If you look at this plot, this is very wide, right? Because the variance is 5.0. Even though all of these are normal distributed plots, the properties of these plots depending upon what is the mean and what is the variance. Is that clear? I hope you understand what are the properties of the normal distribution. So let's say I have a data set D, and I will have so many points xi and yi, and I will say it follows normal distribution, and I will also say its mean is equal to 0 and sigma square, which is called variance, equal to 2. So if I know this information without even looking at my data points, I can draw the plot of the data set, right? So this will be something like this, and this is at 0, and this value is 2, and it is symmetric across 0. So this is how my data looks like. Even though I am not looking at the data points, by knowing that it follows normal distribution, and I know the value of mu and sigma square, which is variance, I get to know that, okay, this is how my distribution is for this data set. So that is the importance of understanding what kind of distribution your data is. Hopefully that is clear. And let's understand a little bit of math regarding normal distribution. If you see, this is the formula for calculating the values actually. So your y equal to 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by sigma whole square. Clear? So this is the formula to calculate it. Let's not look at it and get scared. Let's simplify this actually. So let's go back to our notebook and understand what this formula signifies and how you can interpret this formula. So let me write that formula. So we have f of x equal to 1 by root 2 pi sigma x exp of minus x minus mu whole square by sigma square, 2 sigma square. So this is the formula, and this we also call it as a normal distribution. And let me explain the notation of a normal distribution. So what we have a random variable, which is continuous random variable x, and we will represent the x, and it belongs to normal distribution n, such that the values of mu and sigma square are this. So when I say I have a data set which follows normal distribution, it mu equal to 0, sigma square equal to 2, I will represent something like this: x belongs to normal distribution of 0 comma 2. So this is the distribution of my data set given these two properties. Is that clear? So this is basically p of x1, and this is this one. So let's simplify this. So how do you simplify this? Let's take values as mu equal to 0, which my main value as 0, and sigma square equal to 1. Clear? So this will become what? 1 by root 2 pi, because sigma is 1, and I will say exp of minus x minus 0, which is x square, by 2, right? So this is my whole formula. So let me get this here. So f of x equal to what my formula turned out to be: 1 by root 2 pi exp of minus x square by 2, right? So this is a constant value and 2 is a constant value. If I have to generalize this, this would be something like y equal to exp of minus x square, right? So if I draw this plot, this will be something like this. So whatever the equation that we have here, we converted that into a mathematical equation, and that is the equation of a normal distribution. So if you look at it, after, let's say, x is equal to 0.8 and x equal to 2, the drastic decrease from 0.8 to 2 is too much fast, right? Because what is the equation? Y equal to exp of minus x square. What is exp? Basically e power x, exponential function. So this is basically e power minus x square. It is basically 1 by e power x square. The value decreases in a very fast exponential way. Hopefully you understand the properties of a normal distribution. So let me rephrase what we have learned so far, and then we will move forward. So we have seen what is a normal distribution, what is a bell-shaped curve, and how in the real world most of the things follow normal distribution. We have seen an example of people's height, and we have also seen an example of people's weight, and then we have seen the properties of normal distribution, which is the mu and sigma square, and then we have also learned about it is always symmetric, and as the value of x increases, the value of y decreases, no matter if it is a positive value or a negative value. And then we have also seen, based upon sigma square, how your width of the plot will increase or decrease. So these are all the properties of a normal distribution. And because we learned all of these things, whenever we say a data point D which follows normal distribution with these two values, I can apply all the things that I learned from normal distribution even without looking at the data point. And then we have also seen the mathematical formulation of the normal distribution, and then we have seen the notation of normal distribution, and we have simplified this formula using a constant values, and then we have seen whether this formula applies to the normal distribution or not. Hopefully that is a lot to take. I will suggest you to rewatch this video whenever you are not comfortable, and let me know if you have any queries in the comment section below. I will be able to help you more precisely. I hope you learned something new from this video. And that's all for this video. If you are liking what you are watching, a sub to the channel would be amazing, and click that bell icon to get notified daily. We will meet in the next video. Bye bye.